Hi everyone. Thanks for your interest in our work. My name is Jianing. You can just call me Janice. Today I would like to present our work, Understanding User-Perceived Security Risks and Mitigation Strategies in the Web3 Ecosystem, which was conducted with Tanusree Sharma and Kanye WANG. In the traditional web server architecture, also known as Web2, large internet companies offer a range of services. Take TikTok for instance, users can watch and upload videos, interact with other users, and even shop within this platform. Additionally, all user data is hosted and managed by this platform. In contrast, within the Web3 ecosystem, user interactions have become increasingly intricate. Users no longer rely solely on a centralized platform for accessing various services. Instead, they must navigate and engage across numerous platforms. Suppose you find an NFT that you like very much on OpenSea, and it sells for 100 tokens. In order to get it, you may need to go through the following steps. Initially, you might explore information about the NFT on community platforms like Discord. Here, you can learn about the artist, historical transaction records, and other users' reviews. Next, you'll need to purchase some cryptocurrencies such as Ethereum. You can use fiat currency like USD or Euro, or other cryptocurrencies like BTC, on centralized exchanges like Binance to buy 0.05 Ethereum. After acquiring Ethereum, you'll transfer it from Binance to your digital wallet such as MetaMask. This wallet will securely store your Ethereum. With Ethereum in your wallet, you'll proceed to exchange it for tokens. Decentralized exchanges like Uniswap facilitate this process. Finally, armed with 100 tokens, you can visit NFT marketplaces like OpenSea and use your tokens to buy the NFT. Once the transaction is complete, the NFT will appear in your MetaMask wallet. Throughout this process, you'll need to navigate and interact across various decentralized applications. In the Web2 ecosystem, the security of user data heavily relies on security mechanisms implemented by centralized service providers. However, Web3's decentralization eliminates the authority of these entities. This means that users must take greater responsibility for their own security rather than relying on other institutions. The unique responsibility of ensuring one's own safety implies that the security of a user's digital assets and even the entire ecosystem is significantly influenced by their security behavior. Therefore, understanding user security perceptions becomes a critical task, as it not only deepens our understanding of user security behavior, but also guides improvements for more robust systems. Currently, research on Web3 security faces two main challenges. Firstly, as demonstrated in our previous example, the Web3 ecosystem involves numerous complex elements. However, the topics we currently encounter are scattered, lacking a systematic understanding. Secondly, the continuous influx of security risks results in user losses. Despite significant technological efforts in the security domain, we remain uncertain whether users are aware of these issues and, if so, how these risks impact their security practices. As we mentioned earlier, Web3 user security behavior is influenced by their security awareness, and their actions may affect the overall ecosystem security. Therefore, addressing this issue is essential. So, our research goal is to establish a systematic understanding of user-perceived security risks and mitigation strategies within the Web3 ecosystem. First, we aim to explore the user interaction framework in the Web3 ecosystem through observational studies, thereby gaining a comprehensive understanding of interaction scenarios within this ecosystem. We extracted key elements from relevant information sources and ultimately synthesized a user interaction framework for the Web3 ecosystem, encompassing 4 distinct interaction scenarios: blockchain system, Web3 decentralized application, off-chain cryptocurrency ecosystem, and online community. This framework provides a comprehensive model for understanding the intricate relationships and processes involved within the Web3 ecosystem. The complete version of the framework diagram includes stakeholders for each scenario, highlighting critical user interactions and essential connections among stakeholders. You can find further details in our full paper. Subsequently, we designed a user study to explore how users perceive security risks across different interaction scenarios. We conducted an interview study involving participants from the Web3 ecosystem, recruiting a total of 21 Web3 users. Thematic analysis was employed to process our interview data, resulting in 2 main themes: security concerns under the 4 interaction scenarios and mitigation strategies. Our first findings focus on user concerns within different application scenarios in the Web3 ecosystem. Firstly, users express distinct worries across the 4 interaction scenarios. While we won't enumerate all of these concerns here, we'd like to share some intriguing discoveries. Let's take smart contract mechanical vulnerabilities as an example of technology-related security issues. Interestingly, participants without a technical background exhibit an absolute blind spot in their knowledge about this topic. Not only do they lack the inclination to delve deeper into understanding it, but they also confidently believe that such issues won't affect them personally. Some even assume that smart contracts deployed on the blockchain are inherently free from security problems. They lack an understanding of the mechanisms behind the smart contract mechanical vulnerabilities. For instance, they remain unaware that attackers can create malicious attack contracts containing harmful code. These attackers can then invoke the victim's contract and repeatedly execute portions of its code through fallback functions, ultimately siphoning off all the funds within the contract. On the other hand, some technically proficient users tend to overly emphasize smart contract code issues, focusing intensely on code logic checks. Unfortunately, this narrow focus can lead them to overlook security risks originating from other aspects within the Web3 ecosystem. Our second set of findings pertains to mitigation strategies. Among these, the most frequently mentioned strategy falls under the category of risk aversion, specifically the approach of trusting the market leader. However, it's essential to recognize that this method merely reduces the probability of security risks occurring. It does not entirely eliminate them. Furthermore, although users actively look for mitigation strategies after becoming aware of security risks, we've observed that the specific measures of these strategies are very subjective, such as psychological management. Certain objectively existing security tools remain underutilized. For instance, tools designed to facilitate the revocation of smart contract authorizations have not been widely adopted. To summarize our main takeaways from this study, firstly, the intricate environment of the Web3 ecosystem, coupled with diverse user security perceptions and behaviors, underscores the need to bridge the gap between user awareness and security risks. This exploration can guide more effective security strategies. Secondly, a comprehensive understanding of user security awareness reflects a holistic view of the Web3 ecosystem's security landscape. It goes beyond narrow perceptions focused solely on specific attacks or vulnerabilities. In essence, we have constructed a systematic understanding of security issues perceived by users within the ecosystem, along with corresponding mitigation strategies. Our research findings can be shared with the entire Web3 community, driving industry security standards and best practices. That's all our sharing today. Thanks to all my co-authors, reviewers, and participants. And also, many thanks to you, our audiences, for your precious time. We also have other interesting findings that have not been presented today, and it is always welcome to discuss with us by email or X.